Welcome back. Today we are working in our workbook starting with page 240. So open up to page 240. And we're going to be talking more today about the relationship between numbers. And remember, by relationship, we mean like, how can you compare them? Can you say that x is twice the value of y? Can you say that y is 3 times the value of x plus 1? So we're figuring out what that relationship is. We do that by looking for a pattern. We can make a table. We can make an equation from that pattern. And then we can graph using different points. Our x and y values become ordered pairs, and we plot them on the graph. All right, cool. Let's look at page 240. All right. Relate quantities using a table, a graph, and an equation. All right. The Booster Club members want to raise $50 to donate to a local charity. They buy pom-poms for 55 cents each. How many pom-poms do they need to sell to reach their fundraising goal? Okay. So it says, again, look for relationships. How can you use a table, a graph, and an equation to analyze the relationship between independent and dependent variables? So let's take a look here. They're selling the pom-poms for $1 each. And the Booster Club raises 45 cents for each pom-pom they sell. Okay, so they buy them for 55 cents. So that means 45 cents is profit. So here's what you would do. Make a table. Relate the number of pom-poms sold, we're going to use N for that, to the amount of money raised. We're going to use R for that. So here's what the table looks like. Here's some N values, and here's some R values. So this means that if you sell 10 pom-poms, you're going to make $4.50. If you sell 50 pom-poms, you're going to make $22.50. If you sell 110 pom-poms, you're going to make $49.50. Okay, so there's your table. Let's look at a way to take those values and graph them. So money raised is this axis here, the y-axis, and number of pom-poms sold is going to go on the x-axis. Now remember that when you're graphing an ordered pair, you always graph the x value first. You could do the horizontal axis first. So if our ordered pairs are 10 and 450, here we've got 0 and there's 10 and there's 450 and 50 is here. And you can see it goes up to 2250 on the graph and so forth. So this point represents the number of pom-poms sold to raise $50. Remember when we left off, 110 would raise $49.50. We make 45 cents on each pom-pom. So just a little bit more than 110 will do it. Let's take a look here. Step 3, write an equation that describes the relationship. So the amount of money raised, R, is 45 cents times the number of pom-poms sold, which is N. So that means that R is going to equal 0.45 or 45 hundredths N. So there's the equation. Now, if we know that we want to raise $50, then we're just going to substitute 50 for the R, because R stands for money raised, and then solve that equation. So what we're going to find out from that is how many pom-poms do we need to sell to get to that 50 value? So what does N have to be that when you multiply it by 45 hundredths, it equals 50? So you'll divide both sides by 45 hundredths, and you end up with 111 and 11 hundredths equals N. So the Booster Club must sell at least 112 pom-poms to raise $50. Okay, say it with me. Try it. The Booster Club now raises 41 cents for each pom-pom they sell. What happened? It must have gotten more expensive or something. So now they only raise 41 cents for each pom-pom they sell. Complete the table and graph. Write and solve an equation to find how many pom-poms they need to sell to raise $50. Okay, so here's our table again. Here we've got 50 for the number of pom-poms, and that would mean they would raise $20.50. If they sold 100 pom-poms, they'd raise $41. If they sold 150, how much would they raise? All right, and they've done it here on the graph as well. So the x-axis down here is for the N. So way over here, at a little more than 150 is what you need to raise. So if you solve that equation, you will find that you need to sell, where are we here? So 122 pom-poms to raise $50. 150 will give you $61.50. Okay? All right, let's look at the next page. 241. Relate an equation with two operations to a table and a graph. So two operations. So it's not just going to be something times something equals something. Maybe it'll be 2 times something minus something else. We'll see. The temperature was 6 degrees Celsius at 8 a.m. and increased by 2 degrees Celsius each hour for 6 hours one spring day. What was the temperature after 6 hours? Started off at 6. It increased by 2 degrees for 6 hours. So what are we going to do to show that? Let's take a look at the table. The temperature T depends on the number of hours passed, right? Because every hour that passes, the temperature goes up a bit. So the temperature is the dependent variable, and the number of hours passed is the independent. So at 0 hours passed, it was 6 degrees, right? Because that's what it started at. And then 2 hours passed, 2 hours. And after 2 hours, the temperature was 10 degrees. And after 4 hours, the temperature was 14 degrees. After 6 hours, it was 18 degrees. So you can see, even though it's jumping more than, it's counting by 2 hour increments, it was 2 degrees for every hour. So for 2 hours, it's going up by 4 degrees. Let's take a look at the graph. Graph the ordered pairs on the coordinate plane. So remember, these become ordinate pairs. So we have 0, 6, 2, 10, 4, 14, 6, 18. Those become ordered pairs. And here's our graph. So starting off at 0, like what was the starting point, was 6 degrees. And then after 2 hours, it was 10 degrees. After 4 hours, it was 14 degrees. And after 6 hours, it was 18 degrees. Okay? Now let's take a look at the equation. Temperature, remember T stands for temperature in this equation, equals 6, that's the starting point, plus 2n. 2 is because 2 degrees every hour, and n is for the number of hours. Okay? So if you substitute n equals 6, see how they substituted 6 in for n there? Then you're going to get T equals 6 plus 2 times 6, or T equals 6 plus 12, which equals 18. So after 6 hours, the temperature was 18 degrees. And that's what the graph shows too. 6 hours, 18 degrees. Okay. Hey, cameraman, will you say it with me too? Ready? Try it! A company makes decorations for pens. Okay, this one made me giggle. What the heck is a decoration for a pen? I don't know. All the supplies cost $5, and the company plans to sell the decorations for $2 a piece. Okay. Analyze the relationship between the number of decorations sold and the profit by completing the table and the graph. Use the table and the graph to write and solve an equation to find the number of decorations that must be sold for the company to make a $15 profit. I don't know what's more ridiculous here, calling them pen decorations or that your big goal for your company is to make 15 bucks. Anyway, leaving that aside, let's take a look at this table. Independent variable and dependent variable. We've got the company makes its decorations. The supplies cost $5, and they're going to sell each of those decorations for $2. So let's take a look. So this X value is for the decorations sold, and then the Y value is the profit. Okay, so if you sell 3 decorations for your pens, you make $1. If you sell 4 decorations, you make $3. If you sell 5 decorations, you make $5. And the question is, how many decorations do you need to sell to make $15? Okay, here is the equation that I used. 2x, 2 is the number of dollars that you sell the decorations for. X is the number of decorations that you sell. Minus 5 is because you spent $5 on your supplies. Equals Y, and Y is your profit. So if you substitute 3 in there, you get 6 minus 5 equals Y, which is 1. So then if you keep going and substitute those values in, you figure out how many you have to sell to get your $15. So this is the one this week that I'd like you to bring to the next time that I meet with you. Okay, so if you have a Friday meeting, that means this Friday. If you have a Monday meeting, that means next Monday. All right, let's take a look at page 242. Key concept. Okay, you can analyze the relationship between independent and dependent variables in tables and graphs. You can. I know you can. You can relate tables and graphs to an equation. Yes, you can. All right, let's take a look here. We've got our X and Y values. X is going to be the independent variable, Y is the dependent variable, and here's our equation. Y equals 2x minus 4. Okay, if that's true, then if X is 2, Y is going to be 0. Let's just plug in the values and see if that works. Okay, so Y, if Y is 0, so 0 equals 2 times 2, which is 4, minus 4. Yep, it's true. Okay, let's look at the next one. In this one, the Y value is 2, and the X value is 3. Let's plug it into the equation. Y, that's 2, so 2 equals 6 minus 4. Yes, it does. And the last one, Y is 4, so 4 equals, X is also 4. 4 equals 8 minus 4. Yes, it does. Okay, and here it is graphed over here, those points graphed. 2, 0, so it's right there on the line. 3, 2. 4, 4. Okay? Do you understand? Do you really? How can you analyze the relationship between dependent and independent variables using tables, graphs, and equations? Explain. Okay? How about reasoning? Use the relationship in example 1. How many pom-poms must the Booster Club sell to raise $75 for charity? So you've got to go back to that page and find that information and then come up with the answer. We figured out how much they'd have to sell to raise $50. This is for $75. Construct arguments. For every 4 bananas a grocery store sells, it sells 2 apples. That is a really strange piece of data. Mary wrote the equation 4b times 2 equals A. What is Mary? Does she work for the grocery store? What's happening there? Anyway, 4b times 2 equals A, okay? Where B is the number of bananas sold and A is the number of apples sold. Does Mary's equation correctly represent the relationship of bananas sold to apples sold? Explain. And please explain what Mary is doing in the grocery store coming up with these equations. Okay, I would like you to work on those 3 while you have the video paused, and then come back and check your answers. All right, ready? So what I said was, make a table with 3 values for the 2 variables. Use the values as ordered pairs and graph them. Write an equation to represent. So it's good to show more than one example, right? So 2, 0 is one example. 3, 2 is now you're at 2 examples. It's good to show 3 so that you can really show the consistency. And for this one, they would have to sell 167 pom-poms. I think it's weird that that's an uneven number. And if it's just, because that means that like at least one guy only has 1 pom-pom, which also begs the question, if it's only one, is it a pom-pom or is it just a pom? Anyway, here's what I did. 45 cents times N equals the amount raised. I substituted 75 cents for R, and voila. Okay, now, sorry, Mary, not only do you have a really strange hobby, but you're also wrong. And the correct equation would be 4b divided by 2 equals A. Okay, 4b, that's 4 bananas divided by 2 equals the number of apples. Because if you're selling 4 bananas and 2 apples, what do you see? That's twice as much, right? Okay. All right, let's take a look at the other side of the page here. Do you know how? In 4 through 6, use the equation D equals 4t. Complete the table. D is for distance, T is for time. Name 4 ordered pairs found on the line plotted using this equation. So here's 3 points. What would be a 4th point if you tried to graph this? And then describe the relationship between the variables. Which one is dependent, which one is independent, and what's the relationship? And then in number 7, complete the table and graph to show the relationship between the variables in the equation. D equals 5 plus 5t. D equals distance, T equals time. It's got the graph set up for you. It's got the equation at the top of the table, and it's got a couple of the values plugged in for you. So, for example, if I've got the value T is 0, then D is going to equal 5 plus 5 times T. T is 0, so that's 0. So D is going to equal 5. Complete the rest of that table and graph. All right, pause the video while you do that and come back when you're ready to check your answers. Here we go. Okay, so I completed the table this way. If T equals 1, then D equals 4. If D equals 2, if D equals 1, then, oh my goodness, let me start over. If T equals 1, then D equals 4. If T equals 2, then D equals 8. If T equals 3, then D equals 12. Okay? And here's the first 3 ordered pairs. What would the 4th one be? Well, let's try it. I'm going to put 4 for the value of T, and I know that D equals 4 times T, so that means this would be 16, and your 4th ordered pair would be 416. Of course, you could put anything in there as long as you used the equation to come up with it. What if you put 10? So T equals 10, then D would equal 40, and that would also be true. Okay? Now, Describe the relationship. D is 4 times the value of t. There you go. All right, and for this one, the table completed looks like this. If t is 0, d is 5. If t is 2, d is 15. If t is 3, then d is 20. All right, and there I graphed it. Okay? All right, and let me see. We have one more page today. So let's take a look at page 243. In 8 and 9, complete the table and graph to show the relationship between the variables in each equation. All right, a rectangle is 1/2 inch longer than it is wide. So a little bit longer than it is wide. Let W equal the width and let L equal the length. Remember it said the length is 1/2 inch more than the width. And then graph L equals W plus 1/2. So there's the equation. Let's fill out the table first. If L equals W plus 1/2, when W is 1, L is 1.5. If W is 2, then L is 2.5. So this one is completely blank. Let's put 3 in there for W, and that means that L would be 3.5. Okay, and then you would graph it. So you'd go over 1, up 1.5, over 2, up 2.5, over 3, up 3.5, and then join the points. Not dots, points. Okay, number 9. I want you to do this on your own. The sale price is $5 less than the regular price. S is the sale price. R is the regular price. Graph S equals R minus 5. So first you want to complete the table and then graph those points. Let's talk about the next 3 problems also. The points 2, 4, and -2, -4 are plotted on the coordinate plane using the equation y equals a times x. That dot means times. It's another one of the ways that you show multiplication, okay? So y equals a times x. How can you use the coordinates to find the value of a? Okay, think about that one. You might need to read it again. Points 2, 4, and -2, 4 are plotted on the coordinate plane using that equation. So how can you use those coordinates that you know about to find what the value of a is? Okay, here's the equation, here's the points. All right, without using a table or graph, identify 3 other points that a graph of the equation in exercise 10 will pass through. So what are some more points that you could come up with using that same equation? And reasoning. The Jackson family is planning a weekend vacation. They plan to rent a car from the ABC car rental company. Let M represent the number of miles the family will drive. Let C represent the cost for renting a car. Rent an equation that shows what the cost for renting a car will be. And then you use the information on the sign here. Okay, so pause the video and work on those 4 problems, and then start it up again when you want to check your answer, or if you need a hint. Okay? And here we go. So let's see, with number 9, if R is 10, S is 5. If R is 20, S is 15. If R is 30, S is 25. And there I have graphed it. Okay? Now, let's take a look. So, how can you use the coordinates to find the value of A? So, if Y values are 4 and -4, right? Because they're the second numbers in the ordered pair. And the X values are 2 and -2. because they're the first numbers in the ordered pairs. So if you say 4 equals 2a, and then you divide both sides by 2 because you're looking for a, you get a equals 2. Okay? Now let's take a look at number 11. Without using a table or graph, identify 3 other points. Okay, so if we know this is the equation here, y equals a times x, and we know that a equals 2, then you can say using a equals a times x, and so y equals 2x. If y equals 2x, then you can come up with more points, right? This first column are the x values, the first numbers in the ordered pair. The second column are the y values, or the second number in the ordered pair. So 3, 6, 4, 8, and 5, 10 are more points that you could generate using that equation. Okay? Now let's see how much cost the Jacksons. So M equals miles, C equals the cost of the rental. So C equals 10 cents times the number of miles plus 40. Because it tells you here on the sign that the cost to rent a car is $40 plus 10 cents per mile. So for example, if you rented a car and drove 100 miles, you'd have to pay $40 just to get the car, and then you'd have to pay 100 times 10 cents, which would be how much? 10 cents times 100. Okay? All right. So that is it for today. That was a lot of work. Good work. Thanks for hanging in there and paying attention. I hope you're enjoying this stuff. It's fun, but it's like you really have to engage your brain a lot, right? Okay, I will see you next time. Bye.